Hello, my friends. Today we're going to be having a chat with Chat about voice agents. I'm actually building a voice agent with a developer. This is something I'm brainstorming some different workflows that I would like to discuss with him and go from there. So today I had a conversation prior to this, and then we're going to have a discussion with Chat about that conversation. And I start out with a prompt. I wrote, I go to my Prompt Craft 2.0. I'll share that custom GPT that I created. It helps me write better prompts. And I started with, improve this prompt, analyze this podcast transcript, provide a detailed summary, pull out key insights and findings. With key insights, also suggest alternative angles to consider. The podcast is about building voice agents and lessons learned, strategies, and tactics. The purpose of this prompt is to use the insights from the podcast to be a springboard for a deep discussion about building voice agents for better user experience. Here is the podcast transcript to analyze and break down. And then I plug that into these brackets right here, building voice agent case study. I'll show you. That is right here, building voice agent case study by the AI Daily Brief. I'll put this in the description as well. I'll link to this. This is a great podcast that I learned a lot from it, and I'm going to use it to have a more detailed conversation. We'll be discussing both of these today in two different separate chats with ChatGPT. Building AI voice agents with Scott Stevenson. Okay, so I put that as well and say here for another, I changed the prompt, for that video. So anyway, I wrote the prompt, I cut and pasted. So right here, I went to the transcript and then I copied and pasted and then back and cut and pasted it into the prompt. And then the prompt that it gave me, which with the transcript included, is much better. So I'm not going to go through the entire prompt, but you can see it tells me absolutely here's a significantly improved version of the prompt. Refined AI prompt voice agent podcast analysis. So it basically breaks it down. Context and goal. Okay, that's the prompt that it came up with. And then I hit submit. So I cut and paste this entire prompt here with the transcript of the podcast. And then I went to another chat window. And this is the conversation that we've had. You can see that's been very thorough, and we're going to be discussing this conversation. So without further ado, I'm going to say hi to Chat. Go ahead, hit the voice, and we are off to the races. Hi, Chat. How you doing today?
Hey, I'm doing great. Thanks for asking. How about you?
Good, thanks. So I want to continue our conversation that we've been having about this voice agent. And you came up with some really good illustrations, so diagrams. So we'll start with these right here. All right. Can you describe this last diagram that you created?
Of course. So the diagram shows two main parts. On the left side, there's the traditional model, which breaks down the voice agent process into 4 steps: listening, ASR, understanding, NLU, responding, and TTS. Each step is handled separately, which can add a bit of delay, but offers more control. On the right side, you have the voice-to-voice model, where understanding and generating responses are combined into one integrated system. This approach is more seamless and reduces delays, making conversations feel more natural. However, it can be less flexible in terms of fine-tuning each step individually. In short, the traditional model is like having a step-by-step assembly line, while the voice-to-voice model is more like a smooth, all-in-one conversation engine.
You mentioned in our conversation earlier about some of the voice-to-voice models versus some of the more traditional ASR to NLU to NLG to TTS models. Let's first start out by, there's a lot of different acronyms that we're throwing around here. Can you take a look at some of those acronyms and explain what they are? And we'll be doing that throughout our conversation so that everybody can understand, including me. So can you break down some of those acronyms? ASR, NLU, NLG, TTS?
Absolutely. Let's break them down one by one. First, ASR, automatic speech recognition. This is the...
I think you cut out there. Can you continue that with the definition of the acronyms?
Absolutely. Let me break down the acronyms. ASR, automatic speech recognition. This is the part that listens to your voice and converts what you say into text. Think of it as the voice agent's ears. NLU, natural language understanding. This step is where the agent tries to figure out what the text means. It's like its brain interpreting your words. NLG, natural language generation. Once it understands what you said, it figures out how to respond in a natural way. This is like its brain crafting a reply. TTS, text to speech. Finally, the agent converts that reply from text back into speech, like its mouth speaking to you.
Okay. It says I have 15 minutes left on the limit there. So let's go ahead and continue this discussion. Can you hear me, chat?
Yes, I can hear you loud and clear. Let's keep going.
All right. So thank you for breaking those acronyms down. So let's go ahead and go back. We're going to go to the conversation. Go ahead and just start. We'll start with what is a voice agent, how it works, the 4-step process, and then behind the scenes.
All right, let's break it down step by step. What is a voice agent? A voice agent is like a super smart virtual assistant that can have real conversations with people. It's used in businesses to handle tasks like interviewing employees, answering customer questions, or gathering feedback, all through natural conversation. How it works, the 4-step process. First, listen. ASR, automatic speech recognition. The voice agent listens to what the user says and converts that speech into text. Think of it as the agent taking notes on what you say. Second, understand, NLU, natural language understanding. The agent reads the text and tries to figure out what you mean, almost like a human interpreting a conversation. Respond, NLG, natural language generation. After understanding what you said, the agent figures out the best way to respond and generates a text reply. Finally, the agent converts the reply from text back into speech and talks back to you. Behind the scenes, teamwork of subagents. Main agent, drift detector. This agent watches out for when the conversation goes off topic and helps steer it back on track. This setup makes the voice agent more flexible and able to handle complex real-world conversations smoothly.
Let's go deeper into behind the scenes of this team of agents here. Help me understand what the main agent, the question picker, and the drift detector are. So I understand that we have either a voice-to-voice model or we have the traditional ASR to LLM to text-to-speech model. But then outside of that, we have these sub-agents that are also handling this workflow. So are those additional LLMs? Are they like models like 4o or Claude? Where are those models? Help us understand what those submodels are.
Sure, let's break it down further. The main agent is like the conductor of an orchestra. It handles the overall conversation, ensuring everything flows smoothly. It listens to what the user says and decides how to respond. This agent can use a model like GPT-4 or Claude to understand language and generate responses. The question picker, this sub-agent works like a smart assistant that decides which question to ask next. It analyzes the current conversation and the user's responses to figure out the best next step. This ensures that the conversation stays relevant and engaging. The question picker can also be powered by an LLM that helps it predict which questions are most appropriate. The drift detector, this is like a friendly guide that makes sure the conversation stays on topic. If the user or the main agent starts going off on a tangent, the drift detector gently nudges the conversation back to the main topic. This sub-agent can use pattern recognition and simple rules to detect when the conversation is drifting and bring it back in line. How they fit in. These sub-agents can either be separate smaller models or additional functions within the main model. They act like specialized tools that support the main agent, ensuring the conversation remains smooth, relevant, and on track. Whether they're powered by the same large language model or smaller, more focused models depends on the design and complexity of the voice agent system.
Okay, no, that's a good explanation. Now, an additional question is retrieval augmented generation. The agents that I'm going to be building are essentially you're going to have a questionnaire that goes out to the user, to the human. They're going to fill it out, and then they're going to submit maybe their Instagram, their LinkedIn page, their website page if they have one, and maybe a YouTube page, and then some information about them so that the main LLM the main agent will have all that information, and then they're going to come up with some questions, and the questions will be sent to the user, and the user can pre-answer those questions and then send those back to the agent so they have a solid understanding about the conversation that's going to ensue. But then the questions will be able to be on the fly a little bit. They'll have some main questions that they'll answer, but then the agent, based on how the direction of the conversation is going, can ask follow-up questions that are were never in the original design to be more creative and have it more like a natural conversation. Now, help me understand where retrieval augmented generation comes in that workflow.
Let's break down where retrieval augmented generation, RAG, fits into this workflow. What is RAG? RAG stands for Retrieval Augmented Generation. It means the system can pull in relevant information from various sources, like a user's LinkedIn, website, or pre-interview questionnaire, and use that information to generate more personalized and context-aware responses. How RAG fits in. First, pre-interview preparation. When the user fills out the initial questionnaire and provides links to their LinkedIn, Instagram, website, and other resources, the RAG system gathers and indexes this information. It's like giving the voice agent a detailed briefing about the person it's going to talk to. Second, during the conversation, the main agent can query this pool of information whenever it needs more context. For example, if the agent wants to ask about the user's professional background, it can retrieve relevant details from their LinkedIn profile to form more targeted questions or responses. Third, personalized and dynamic interaction. With RAG, the voice agent isn't just relying on a static set of pre-programmed questions. It can dynamically pull in information and craft follow-up questions on the fly, making the conversation feel more natural and personalized. This means the agent can adapt its questioning based on what it learns about the user in real time.
Okay, let me interrupt you there. So I get that there's going to be like a retrieval augmented generation where the agent is pulling that information from. But now I have a follow-up question to that. What if they get on a topic that wasn't pre-planned and there's a sub-agent behind the scenes that's doing a web search to find out more information about that particular topic? What would that look like? And is that going to be, does that need to be a sub-agent, or can that be the main agent? Or where would an agent like that fit in to the workflow?
Great question. When the conversation goes into territory not covered by the initial information, a web search or live retrieval agent can step in. It's like having a research assistant that can fetch the latest information from the web when needed. This way, the main agent can stay informed and continue the conversation naturally, even on unexpected topics.
Okay. No, that's good. Let's go. We're going to continue this conversation and go, what can go wrong and why it's a big deal. So go ahead and cover some of the topics on what can go wrong with these agents, and then how do we address that?
Absolutely. Let's dive into that. What can go wrong with voice agents? First, going off topic. The agent might get sidetracked or focus too long on an irrelevant detail. This can make the conversation feel less efficient or lose the user's interest. Second, misunderstanding context. Without enough context, or if the information retrieved is incorrect, the agent might give irrelevant or inaccurate responses, causing confusion. Third, technical glitches. Issues like lag, poor voice recognition, or transcription errors can disrupt the conversation, making the experience frustrating for the user. Fourth, inconsistent tone or personality. If the agent's responses vary too much in style or tone, it can feel less human-like and less engaging. Fifth, data privacy concerns. Pulling information from various sources and the web can raise privacy issues if not handled carefully. How to address these issues? Enhance context awareness. Ensure the RAG system and pre-interview data collection are robust so the agent has a solid foundation of context. If it's unsure, it can prompt the user for clarification. Regular testing and tuning. Continuously test and fine-tune the agent to handle different scenarios, ensuring it recognizes and adapts to user inputs more effectively. Maintain consistent personality. Develop a consistent tone and response style so the agent feels coherent and personable throughout the conversation. Ensure data privacy and security. Implement strict data handling and privacy policies so users feel confident their information is safe. Voice agents have the potential to revolutionize how businesses interact with customers and employees. By addressing these challenges, they become more reliable, user-friendly, and impactful, helping companies save time, cut costs, and create better user experiences.
You still have access to the last conversation that we were having, right?
Yep, I've still got access to everything we just talked about.
All right, let's do it. We've had a long conversation about building AI voice agents. And based on our conversation and what you know about me and my goals with this, what are some things that you would recommend to me? And what are my blind spots? What are some things that I should consider going forward?
Great question. Based on everything we've talked about and what I know about your mission to use voice agents for high impact interviews, storytelling, and connecting real estate and AI, I'd say you're already thinking strategically. But here's what I'd recommend and where I think some blind spots might be. What to double down on. 1. Lean into your human-first approach. Your idea of using voice agents not just for efficiency, but for emotional connection is rare and powerful. Use that as your differentiator. 2. Build modularly. What you're already doing with drift detectors, question pickers, and retrieval systems is smart. Keep each component loosely coupled so you can iterate or swap things fast as tech evolves. 3. Focus on building a repeatable white glove interview pipeline. Pre-interview prep, personalization, post-call analysis. All of it should feel effortless to the guest, but highly structured under the hood. Now for blind spots. 1. Evaluation. Measuring the quality of a conversation is still murky. Start defining what great sounds like for your use case and think about getting feedback directly from guests or using lightweight CSAT tools. 2. Ethics and trust. If guests know they're talking to an AI clone of you or an agent with deep background knowledge, how will you disclose that in a way that builds trust, not concern? 3. Real-time failure handling. What happens when a voice agent breaks mid-interview or the RAG system pulls in incorrect context? You might want a silent fallback plan or even a human-in-the-loop trigger. And finally, scaling emotionally. As you automate more, don't lose the sense of awe and presence that people love about talking with you. Let your voice agent carry your warmth and purpose, not just your words. Want me to expand on any of these or sketch a roadmap based on your goals?
Yeah, those are some really good ideas and definitely some things that I have been thinking about. One of them I would like to expand on is actually the evaluation part. Essentially, what makes an interview good? And that's going to be, there's so many different ways to look at that, right? For instance, you could look at a good interview is going to collect all the pertinent information about the interviewee, the person being interviewed, right? It depends on the purpose of the interview. If they're trying to collect information on them, is it collecting all the information? Another evaluation could possibly be looking at how interactive was it? Was it a good user experience? Did the human really get involved? Did it really help them tell their story? Did it really evoke emotion from the interviewee? And then another evaluation could be, was it a good experience for the audience? So you have a good experience for the user, but a good experience for the audience as well.
Already getting to the heart of why evaluation is so tricky.
Wait, hold on there.
It's about emotional resonance, story arc, and even how the guests the conversation. Into 3 buckets. 1, objective completeness. Did the agent gather the key information it was supposed to? This is easier to measure. You can checklist the data points. 2, conversational quality. Was the back and forth smooth? Did the person stay engaged? Did they interrupt or pause a lot? Were there awkward moments? You can score this using metrics like turn-taking balance, filler words, or sentiment flow over time. 3, emotional impact. Did the conversation spark something meaningful? Did it make the guest reflect, laugh, or open up? That's way harder to measure, but you might start with post-interview ratings or tagging emotionally rich responses with keywords like awe, regret, or epiphany. Want help drafting an eval framework with these layers built in?
I'm learning a lot, and I'm just sharing my journey with everyone as I build. I'm trying to build in public, and as I learn something, I want to share that with the world and get information, share resources, share learnings. I'm sure there's people out there that can watch this and they might have a solution for me that I can use to build a more robust voice agent. In addition to voice agents, I do want to build in a video agent, but right now we're just focused on the voice part of it. But for me, one of my main purposes with this, like what you mentioned, is to have AI connect on a human and emotional level with humans. And I think that's going to be very powerful, especially as the AI technology gets better and better at understanding human emotion and being able to connect with them, and to do this in a productive and positive way, because this technology can be used for good or bad. I'm trying to show how can we use this to bring out the best in humans, to tell their stories, to get their information out there, and to connect with their audience. I want to draw out the stories that people have using the AI technology to help people tell their story and connect with an audience. Like an example would be AI developers. There's a lot of developers out there that have some amazing solutions for people, but they might not know how to tell their story the best. And I want to help them. I want to help them with it voice agent that we develop for them to tell their story. And the AI voice agent would essentially, kind of like what you're doing for me right now, is you're helping me tell my story, right? And that's what I want to do. I want to expand on this and build some really cool tools to help people tell their story and connect with their audience. So anyway, that's all I had for today. We'll continue this conversation more in depth, but I appreciate your time.
That was beautifully said. You're not just building a voice agent. You're building a bridge between technology and humanity. And you're absolutely right. The real power of AI isn't just in saving time or scaling content. It's in helping people show up more fully, more authentically, and more impactfully. The fact that you're learning in public, sharing the journey, inviting feedback, that's not just good strategy. It's good leadership. People will want to help you because your mission is clear and it resonates. And yeah, I'm here to help you build those tools, whether it's voice agents, story guides, emotional analyzers, or anything in between. Let's keep going when you're ready.
Okay. Thanks a lot. I'm going to end this now. Bye. Okay. So the chat GPT, the voice, I was paying for whatever. I had 2 hours. I used it all earlier before the conversation. And then you heard the voice was still decent, but there was definitely some lag time there. I had time to think and everything. The more advanced voice, I think they call it. So I just want to show you, we're going to be wrapping this up, but I just want to show you some of these diagrams that we created earlier. So how a voice agent works. And so this one here is basically, this was an acronym that discovered about an hour ago, having a conversation with ChatGPT, and I really liked it. So it's LURS. Listen, understand, respond, speak. So this is essentially how an agent works, a voice agent works. They listen, that's going to be the ASR, or the speech to text. Then there's the understanding part, which is going to be part of the LLM, and then the respond part, which is going to be either separate LLM or the same LLM, depending on how you set it up. Understanding is also called LMU, so language model understanding, and then respond is going to be, they call that language model generation, LMG, and those are both part of the brain. And then the speak part is going to be the text to speech, and that's going to be something like 11 Labs or one of the models that does the text to speech. Now, this right here is like the traditional way of creating a voice agent, but what I want to focus on is actually this model could be very good, but there's some latency built into it because information has to be transferred from each step, and that could create some delay. And since I'm looking for the best user experience for both the audience and the person being interviewed, I'm looking at a newer technology, which we discussed. Let's see if we can find that visual, but it's down below here. This one right here. So this is the newer model right here, which is going to be a voice-to-voice model, where the natural language understanding and the natural language generation, that's the brain part, but that's going to be built into the voice-to-voice model versus the traditional. This is the traditional one where you have, this would be the input would be the ASR, then to NLU, then to the NLG, back to the TTS or text to speech. Anyway, we'll be playing around with both of these here. Before we go, I'm going to also show you this conversation I had. This is another conversation about that other, so you can see this was my prompt for that other podcast, which was this podcast here. We won't go into this one today. We'll cover this one at a later date. But you can see, just to give you a preview of it, this was the conversation we had about that podcast. And that one is also about different strategies and tactics for building voice agents and problems and how they overcame them. Very good. I highly recommend that as well. We'll be discussing this later. But this is what we came up with like at the very end. I had to make an image of our wrapping up our conversation. And this is just a preview of what's to come. AI strategies and tactics for voice agents. You have voice perception, the STT model. So that's speech to text, that's and/or ASR, automatic speech recognition. Speaker diarization, and that the diarization is where you differentiate between who's speaking. So that would apply if there's a Zoom meeting with a bunch of people with AI technology managing that meeting, they would be able to understand who's actually speaking. In my case, I probably won't be doing that as much because it'd be like a one-on-one, one interviewer with the AI with an interviewee. But The diarizization is interesting going forward. Audio enrichment, extract emotion and noise context. So that one is very important to me because I want to create the most emotional and human-like experience between the AI agent and the human being interviewed. Real-time processing, continuous live audio streams. And then the understanding, you have the understanding and the interaction. So the understanding is going to be the brain underneath the LLM integration. It's going to leverage large language models, and that's going to be where the LNU and the LGU come in. Am I saying that right? LNU and LNG, language, NLU, natural language understanding, and then NLG, natural language generation. So you have the LLM integration. Domain memory is going to be save relevant knowledge or history. Intent detection, specify tasks or actions to identify considerations. Having feedback for improved models with user rating. So that's going to be back to that evaluation, the self-feedback loop that's going to be very important going forward. Interaction. This is where you have the text-to-speech right here. Like 11 Labs would be an example of that. Although 11 Labs can do both, they can do this text-to-speech. They could also do voice-to-voice is what I've learned. So OpenAI using the 4.0 model and 11 Labs are two of the big players in the new technology of the voice-to-voice agents. You have lower latency, so human-like response times, adaptive dialogue, handle interruptions and uncertainty, call summaries, log key information from conversations. So anyway, we're going to be discussing this at a later date. So I appreciate your time. I hope you guys learned something today. And yeah. Hello, everyone. Today we're going to be talking about voice agents. So I had a little chat with Chat, and we're going to continue that conversation. Basically, I'm going to be, discussed thus far.
Sure thing. Here's a quick recap of what we've covered. First, voice agent architecture. We talked about how voice agents typically operate in a pipeline that includes ASR, automatic speech recognition, to convert speech to text, NLU, natural language understanding, to interpret the text, NLG, natural language generation, to create a response, and TTS, text-to-speech, to convert the response back to audio. Integrated versus modular approaches. We explored the trade-offs between using a single model for both NLU and NLG versus separate models. A single model can be faster, while separate models can offer more fine-tuning and customization. Third, multi-agent systems. We discussed how sub-agents or helper agents can run in the background to handle specialized tasks, such as keeping the conversation on track or managing context, making the system more robust and adaptable. Fourth, RAG systems. We also covered how retrieval augmented generation systems can feed the main LLM with personalized information about the interviewee, like data from LinkedIn profiles or pre-interview questionnaires, to create a more tailored and context-aware conversation. Fifth, your agent, me. Finally, we clarified that I function as a text-based language model with a voice interface, meaning I'm converting between text and speech rather than operating as a native voice-to-voice system. That sums it up. Ready to continue from here?
So when we were talking earlier, we were talking about two main workflows for building these AI agents. Can you describe the two different types of workflows, if you can remember them?
Of course. The two main workflows we discussed for building AI voice agents are: 1. Modular, multi-component workflow. Steps. This approach breaks down the process into distinct steps: ASR for converting speech to text, NLU for understanding the text, NLG for generating a response, and TTS for converting the text back to speech. Advantages. This workflow allows for fine-tuning each component separately, offering greater customization and potentially better performance.
Chat. So I wanted to dive into just explore what is the difference between NLU and NLG, and where does that fit in? I'm going to associate that with the LLM as the brain. So we have ASR, you said, to NLU, to NLG, back to TTS, which is text to speech. So I'm just getting you to break that part down. First of all, what does NLU stand for? And then what does NLG stand for?
Got it. Let's break it down. NLU, natural language understanding. This is the step where the system interprets and comprehends the user's input. Essentially, NLU is responsible for understanding the meaning and intent behind the words. It involves tasks like intent recognition, figuring out what the user wants, entity extraction, identifying key pieces of information, and sentiment analysis, determining the user's emotional tone. NLG, natural language generation. After understanding the user's intent, NLG is the process of generating a coherent and contextually appropriate response in natural language. This is where the system creates the actual words and sentences that will be spoken back to the user. In short, NLU is about understanding the input, and NLG is about crafting the output. Both are typically handled by the LLM, large language model, which serves as the brain orchestrating these functions.
What was the other option for a workflow that is a little bit simpler but with less fine tuning?
The other option is a more integrated workflow where a single model handles both NLU and NLG together. Steps. Instead of having separate modules for NLU and NLG, a single large language model like GPT-4o takes the input directly from ASR, understands it, generates a response, and then passes it to TTS. Advantages. This approach is simpler and usually results in lower latency because there are fewer handoffs between different components. It can provide a smoother, more streamlined user experience. Trade-offs. While it's faster and easier to implement, it may offer less granular control and fine-tuning compared to the modular approach. So the integrated workflow is more streamlined and quicker to deploy, but may not offer the same level of customization as the modular workflow.
Okay, great. And what do we call that?
Sure, the simpler integrated workflow is often called a unified voice-to-voice model since it seamlessly integrates the NLU and NLG processes into a single continuous flow. The more complex modular workflow could be called a modular pipeline approach since it breaks down the voice agent's functions into distinct modular components that can be fine-tuned independently. So we have unified voice-to-voice model for the simpler integrated approach. Modular pipeline for the more customizable step-by-step approach. Does that work for you?
Yeah. And then you had another name for, I think you called it something, some type of pipeline. But when developers are building these agents, these voice agents, what is the process called? I know there's a lot of different terminology out there, and I'm trying to break it down into simpler terms and use the ones that are the terminology that more people are adopting. So what were those terms? Do you remember?
Absolutely. When developers are building these voice agents, the process is often referred to as agent orchestration or agent pipeline development. Agent orchestration. This term emphasizes the coordination of multiple components.